International Space Station Flight Control Room in Houston, and the teams here in Hawthorne and the Dragon will be able to resume its approach. So again, we're just 180 meters away right now, eventually going to be flying in shortly to a spot just 20 meters away from station. But with that hold demonstration now complete, that actually just means there's one more demo planned for this flight. So far, Dragon obviously conducted a successful launch yesterday to bring it into its initial orbit, and then the Dragon spacecraft has conducted a series of demonstrations on its way to the space station. And that included checking out the GPS unit multiple times, 2 different times, both checking its own GPS coordinates against ground models down on Earth, and also checking them against the GPS on board the International Space Station. Just about 2 hours after the launch, it did a demo of its Draco thrusters using 2 thrusters on the front of Dragon just to do 2 burns to simulate abort capability. And then it's done all of these demonstrations so far. The crew initially turning on a blinking light just to make sure they could command the vehicle, and then just executing this retreat and hold demonstration. There's one more that's going to be called the controllability, where they're actually going to set the speed of the vehicle just to mimic docking, just for a short period of time as they go back past waypoint number 1, which is 150 miles away, or meters away. Meanwhile, the team's right now conducting that final go, no-go poll at the hold point, at which point they're going to get ready to resume the approach, move past waypoint 1 down to waypoint 2, and only be 20 meters away.
You just heard that it sounds like Dragon is... Oh, still waiting. So we are hearing that Dragon has been cleared to do the approach towards waypoint 2. That is, again, only 20 meters away from the International Docking Adapter.
Station Houston on 1, Dragon is resuming approach to waypoint 2. Monitor per step 7 in 1.102. Dragon approach and retreat monitor.
Dragon is currently resuming its approach towards waypoint 2. Again, after that commanded retreat, it went back out to 180, maybe 170, 180 meters away, was commanded to hold, and it has just been given the go-ahead to re-approach back to waypoint 2.
That's right. The teams here in Hawthorne giving the command to Dragon, so it's once more on that approach. And again, everything's going to be really slow on this approach, closing in at a rate of just about 1/10 of a meter per second or so. They are going to slow down speeds to just about the docking speeds once they pass waypoint 1 in one final demonstration. But we are on the way now towards waypoint 2, so Dragon's going to start closing in.
In station range 164.
See a little bit more clearly now. That's the nose cone of Dragon that's currently open. Again, hinged and opened up on the sort of top side of Dragon from this view right here from the International Space Station.
And you'll hear Anne McLean, the NASA astronaut on board, radioing down on the space grounds as she and David St. Jacques have been monitoring and commanding the vehicle throughout all the operations today. Dragon, once it gets to waypoint 2, it's going to stop. The teams in the meanwhile are going to be conducting a go, no-go for docking. So that's the final go, no-go poll that we'll do today, and that's the one that's going to get us really excited, because then it's time for Dragon to actually dock to the space station. Dragon's going to make that initial soft contact using the adapter's soft capture ring, which is then going to retract to bring Dragon in for the hard capture sequence. And that's where a series of hooks will actually close in to really tightly secure Dragon to that International Docking Adapter. As a further precaution, Dragon's soft capture system has a set of rotary spring dampeners just to lessen the force of that contact between the spacecraft and the International Space Station. One interesting note, though, unlike Soyuz dockings, where the Soyuz spacecraft and the space station go into free drift, so all the thrusters, all the attitude goes off just to lessen any of that force between the spacecraft's docking mechanisms. It's not going to happen for Dragon. Both it and the International Docking Adapter are robust enough that the station's going to remain in attitude control. That's at least that's a preferred preferred means of controlling the station, obviously, for the flight control teams, just so they can continue to keep the station in its right attitude. So that will be a notable departure from what we see for Soyuz dockings for this one.
That is right. NASA developed the, along with the International Docking Adapter, they developed the International Docking System Specification, which is then used by SpaceX and other visiting vehicles to develop their docking systems on board the spacecraft. SpaceX has developed the SpaceX docking system, which is a little bit different than other types of docking systems. It actually uses those passive springs that Dan was just mentioning. The soft capture ring, we actually might be able to see it very soon as Dragon gets closer and closer, is a ring about maybe 2 or 3 feet wide. It's about the same diameter as the hatch, and it has 3 pedals positioned at about 120 degrees apart from each other. The International Docking Adapter also has these pedals. It's what we call an androgynous docking system, so the pedals can interleave together as we get closer and closer to contact. That contact will be sensed as soon as the soft capture ring gets close enough to actually latch into the opposing pedals of the International Docking Adapter. There are buttons all around the inside of those soft capture ring pedals, and as soon as they're compressed, that's when we'll know. We'll have a signal from our telemetry saying that contact has been made, and at that point the latching pawls on all those pedals will have engaged, and Dragon will be caught by the docking adapter. That is just what we call soft capture. It's actually not the full docking mechanism. So soft capture just means that soft docking ring has made contact with the station. The soft capture ring has 6 arms in a hexapod configuration attached to those springs. Once the springs have dampened out any additional maneuvers between the station and the Dragon, it'll then retract, bringing the Dragon closer and closer to the station in for hard capture. That's when we have 12 docking hooks, hard capture hooks, that will activate from the Dragon side and grab onto hooks on the International Docking Adapter side. And when that happens, that's when hard capture has occurred.
Yeah,
this will all make a little bit more sense when we can get a better view of the docking adapter on the Dragon as it gets a little bit closer. Right now we are approaching towards waypoint 2.
And we are just a couple of minutes away. We just heard Ann McLean radio down that we're inside of 100 meters.
Copy all.
There we go, getting a good call again from Ann McLean on the space to grounds. Everything looking good so far with Dragon's approach. We're about 80 meters or so away from the station, so only about 60 meters to go until we're going to get to that final waypoint for this evening, morning, whatever time of day it is today, and then it's going to hold at 20 meters. And right now the teams are going around doing their final go, no go for docking. So after we get to that final hold point at waypoint 2, it'll be time to move in and use that docking adapter for the very first time.
And we here at SpaceX are so excited to see these systems. They've been tested hundreds of times in conjunction with NASA. There's actually a docking system simulator that we've used to make sure that these mechanisms will work ahead of time, and everything looks really good so far. We're just so excited to see these things happening in space for the first time.
I'm getting the views back from the cameras on Dragon itself. Again, you can see that docking adapter coming into view. It's not going to be directly in the center line. This is actually a separate camera. The center line camera being fed to the crew members on board the International Space Station. That's why it might look a little off center from the heads-up display that you can see on the screen when we have it up. But everything looking good. Again, on board the station, 2 astronauts, Canadian David St. Jacques and NASA astronaut Ann McLean inside monitoring the vehicle. You'll hear them refer to the RPOP, which is the Rendezvous Proximity Operations Program. That's just the name of the program that they're using on a laptop inside of the station to actually monitor Dragon. And as they just demonstrated a little while ago, the crew has the ability to send commands to make Dragon hold or retreat or even abort if they see anything that looks a little out of sorts with its approach. But everything going real smoothly so far. We should be just about 2 minutes away.
In the corridor, orientation as expected.
Copy all.
All right, another good call down. We're about 50 meters away so far, so only 30 meters to go, and then we're at waypoint 2.
Once we're given the go-ahead to approach from waypoint 2, the next big calls we're going to be looking out for are that soft capture contact and then hard capture. You can start to see the space station in great detail here. Again, this is from a view of the forward media cam at the top of the Dragon 2 module. Just to reiterate, this camera is not directly on the center line of the docking axis. This is a fantastic view of Dragon in the sunlight from the International Space Station. So normally when we're getting views from the Dragon for this webcast, you're going to be seeing a camera that's not quite on the center line, so it's a little bit off, and it may not look like we're heading directly towards the docking adapter, but if we're lucky enough, we might get some views from the center line camera in the very center of the hatch from the space station, and you can see us kind of heading on right in. Right now, this is an unbelievable view from a space station. You can see Dragon 2 in full light with its nose cone open, its soft capture ring deployed. You can actually start to see those 3 pedals that I was talking about earlier on that ring, 120 degrees apart. part. That ring is extended above the hatch by 6 hexapod arms that are all attached to Dragon by springs. So that will be the first part of Dragon to make contact with the ISS. And when it does, those springs will compress and absorb and dampen any of the relative velocity differences between the space station and Dragon. This soft capture system was actually subjected to extensive testing and the 6 degree of freedom dynamic test system at NASA Johnson, and this was actually the very same system they used to test other docking systems at NASA.
And we're hearing that Dragon is now at waypoint 2, about 20 meters away from station. So again,
Station
Dragon's
Houston
just
in
going to
1,
hold
20
here.
meter hold confirmed. Perform step 8 in 1.102. Dragon approach and retreat monitoring.
In station for step 8, we can confirm
really hard to
vehicle
believe what
mode
we're looking
is hold. Minimum range observed was 19.75. Orientation is expected. Vehicles in the corridor and holding at 20. Performing review.
Right now you're seeing a view from that
you.
center line camera. This is rebroadcast from the International Space Station. So this is what the astronauts on the station are seeing. And it looks like it's aligned right and ready to dock. It's what I was saying before. It's sort of unbelievable. This is the same spacecraft that we saw yesterday on top of the Falcon 9 at Kennedy Space Center. Now it's in space just 20 meters away from the International Space Station.
Yeah, and it's all coming to this. It's all coming to that go for docking, which we're going to stand by again. The teams are now going to be doing kind of their final go, no go poll, and then they're going to get the call, and we're going to hear it, and it's going to be Dragon is go for docking. So just 20 meters away, successful hold. I didn't comment earlier, but we did hear that there was a good controllability demo. Again, that was just a demo, just slowing Dragon down to basically mimic the final speeds that it'll be at for docking, and that was also done successfully. So we're going to stand by, continue to get this great view of Dragon, and wait for that final go for docking. All right, and right now we're just continuing to hold Dragon still just 20 meters away from the space station, and all the teams now just taking a final look at the data. Dragon's moved through all the demos so far without any issues, not tracking any on the spacecraft, and continuing to get some good views as we do have that signal with the International Space Station. So holding at 20, and then we're going to be listening for the final go, no go for docking, and it'll be time for Dragon to close in.
This is currently a beautiful view of Dragon 2 in full sunlight. Many of us at SpaceX have waited years for this view, approaching the International Space Station. Just a quick note about the features you can see on the Dragon 2 from this view. Obviously, the big structure at the top is the nose cone in its retracted position. It rotates away from its stowed position for launch and back towards where it is right now for docking and orbital operations. You can also see that soft capture ring. Right now, it's deployed and out in front of the hatch. A bit tough to see the distance between the soft capture ring and the hatch, but it's standing off just a little bit and ready to make contact with the International Docking Adapter.
Send station crew is ready for docking.
Those 4 Draco thrusters around the hatch.
And we copy.
And we just heard Ann McLean report the crew is ready for
And we're
docking.
currently assessing lighting.
And that call back from the Capcom in Houston, Leslie Ringo, just the teams looking at the lighting. As Tom mentioned a little while ago, the sun is expected to set in about 12 minutes on the station and Dragon, so they'll be heading into an orbital nighttime. So I think they just want to make sure they have all the right conditions for the final approach and docking of this spacecraft. Again, the crew is going to be monitoring, and they're using that centerline camera now to monitor primarily from that 20-meter point all the way in. they're going to continue to be in the loop all the way up until just 2 meters away, and then we might hear a call out over the Space and Grounds CHOP, which stands for Crew Hands Off Point. And that just means everything at that point is in the hands of Dragon and the space station, including abort commands.
One important thing to remember here, and this sort of just blows my mind every time I stop and think about it, is Dragon looks like it's perfectly still with respect to the space station, and it is, but both the space station and Dragon are moving at 17,500 miles per hour in orbit around the Earth. The orbital mechanics and math required to line these two spacecraft up together is just sort of mind-boggling, and it's always impressive to see it happen in real time like this.
And Station Houston on 1. While we're holding here, please command the docking light to on, ON.
Copy, commanding docking light on.
And so the crew is going to command the docking light on Dragon.
Can we copy?
And then we hear confirmation that the command's been sent. Again, this is what the astronauts on board are looking at right now. This is that centerline camera that they're using to watch as Dragon makes that final approach. The team's all looking at systems, and they're also looking at the communication coverage between here and the International Space Station. They do want to make sure we have a good signal for that final approach and docking, so we might be standing by for a couple of minutes. Dragon able to dock in daytime or nighttime, that is not going to matter for today's operations, but they are going to be looking to make sure we have a strong signal, and we might have a short dropout coming up in just a couple of minutes. So we're going to stand by. Dragon's continuing to hold at just 20 meters away.
You mentioned that docking light being turned on. This is special for me, even in particular, having worked on both the communication system between the Dragon and the space station, and also on that centerline camera module, which has the LED that they were talking about. I spent months at SpaceX with a unit of that on my desk testing that LED, and to see it happening in space is truly extraordinary.
I was going to ask. So Tom basically built the spacecraft. What is it like to see it sitting there? It looks unreal.
For me and everyone else at SpaceX that has poured their life force into this vehicle for the past how many years. It's unbelievable to see this thing flying for real. Like I said before, it's kind of wild to see this just 24, 27 hours ago on top of a Falcon 9, and now in space. It's sort of just a dream come true, is what I'd say.
And you can see the shadows starting to creep along Dragon. Again, we are going to be heading into that orbital nighttime shortly, as both Dragon and the International Space Station flying over the Indian Ocean right now. They're actually a couple hundred miles south of Australia, right between Australia and Antarctica. And pretty soon they're going to be crossing the Terminator line. That's the line separating night from day on the Earth's surface. And so things are going to get a little bit darker, but that's why we heard the crew get the call to turn the docking light on.
Sunset so that we have a good view of the backlight.
Mission copies.
And you just heard that call up to the station. So they are going to wait until sunset, until they resume that final approach. And then sunset is scheduled to come in just about 7 minutes from now at 45 after the hour. So we're going to stand by, continue to get these views of Dragons. We're going to lose signal for a couple of minutes shortly, and then that's going to lock back up right as the sun's going down. And then we'll be ready to move Dragon in from that 20-meter hold point to the docking. We're almost at docking.
There. So don't go anywhere. We're going to hold for just a few minutes. Sunset is expected at 2:45 a.m. Pacific time. So as soon as that happens, we'll be able to continue with the docking. Stand by.
Station copies. Vehicle mode is approach to docking port. Primary range is decreasing. Vehicle is centered.
Copy all.
And getting good reports from Ann McClain there on board the International Space Station. Dragon is approaching, everything in on the center, and still looking good. So the crew is using that centerline camera on the Dragon spacecraft just to do all of their final monitoring of the vehicle. This camera a little off center. This is not the one the crew's using, but this is one that we have. But you can see now that international docking adapter. It's attached to a larger black piece of the station. That's a pressurized mating adapter, which is then attached to actually one of the modules, which is known as Node 2 in the Harmony. It's the Harmony module. So Dragon continuing to close in. It's expected to take just about 5 minutes or so, and there's a great side-by-side look. One view on your left from Dragon, one view on your right from the International Space Station.
On the view on the left from Dragon looking at the space station, we can finally see those details of the international docking adapter. The IDA is a passive system, and the Dragon contains all the active components of that docking system. You can actually see those androgynous petals, those three petals that are kind of sticking at 120 degrees apart from each other on the IDA on the left-hand side. In the very middle is actually a visual docking target that the astronauts can use to judge whether or not the Dragon is right on course. It has a little stick that comes off from the center of it, so you can see the stick's shadow and determine whether or not you're directly on center in all three axes. Like Dan said, this camera view on the left from Dragon is not the centerline camera. It's actually the forward media cam.
Range is 9.5 and decreasing. Vehicle is centered. Largest excursion observed is less than half a meter. And less than half a degree.
Copy.
All right, we're inside 10 meters. Halfway there.
Like I was saying, this camera view right here is just a little bit off center from the center line, so it may look like we're not approaching that IDA directly head on, just because the camera's not in the right position, but the crew has that center line camera, which is directly dead on. And as long as we keep hearing these good callouts, it sounds like Dragon is dead right where it needs to be. And there it is, there's that center line camera view that the crew on the International Space Station is using. They use the overlays to figure out, and that visual docking guide right there to make sure that Dragon is exactly where it needs to be as it approaches. On the right-hand side, you can start to see the mechanisms of the SpaceX docking system aboard the Dragon. The very first part of Dragon that will make contact with the ISS is that soft capture ring. You can see it's extended forward from the hatch of the Dragon right now. As soon as those pedals make contact, latching pawls will engage and hold the pedals against the opposite ones on the IDA, and contact pins will depress, and we should hear the call out for soft capture achieved.
Hands off point.
Copy.
All right, so we're at that crew hands-off point. That means we're about 2 meters away. Crew no longer sending commands. Dragon doing everything on its own.
Soft capture confirmed.
Mission confirms.
You can hear the cheers behind us at SpaceX headquarters in Hawthorne, California. We have confirmation of a soft capture of the Dragon spacecraft to the International Space Station. You can see in your view the Dragon's still moving around a little bit. That's the soft capture ring is attached to Dragon by way of 6 arms that are all attached to springs that help dampen the motion, the difference in the relative velocities between the Dragon and the space station. This is unbelievable news for everyone here at SpaceX and at NASA.
Yeah, that capture, that docking coming at 2:51 a.m. Pacific, 5:51 a.m. over on the East Coast. As the International Space Station and Dragon were flying just about 260 statute miles over planet Earth, just north of New Zealand. So
ring retraction in progress.
Docked. Well,
no, we're not quite there yet.
Not quite there yet.
So we've achieved soft capture, which is what the call it you heard. So the next step is going to be hard capture. Hard capture is achieved via 12 latching hooks that are all around the inside of the Dragon hatch, and they'll actuate and grab onto hooks on the other side and pull and hold the Dragon tight against the ISS.
That's right. This whole process expected to take about 15 minutes. So first that soft capture ring is going to retract, and then the hard capture sequence can begin its process. That'll take about 12 minutes. And then there are 2 umbilicals that will actually get mated to the Dragon spacecraft from the station, and that is to provide power and data to the spacecraft and transfer that over to the station. And at that point, it will be fully attached and ready to stay for the next 5 days. So again, that capture coming at 2:51 a.m. Pacific time, 5:51 a.m. over on the East Coast, as the Dragon and station were flying just north of New Zealand. So there we go.
And you can imagine this, this is unbelievable for everyone here that's worked so hard on Dragon and with NASA. You can imagine that soft capture retraction, sort of like Dragon doing a pull-up and bringing itself closer to the station to get those hard capture hooks ready to go. Like I said, this is going to take just a few minutes, so the whole process takes about 15 minutes to get the soft capture ring retracted, the hard capture hooks engaged, and then those umbilicals mated. So we still got a little bit more ways to go here. Dragon is attached, and we're all very excited about that, but lots more to come.
Yeah, we're gonna hang out until that hard capture and everything is complete, and then after that, the action's not over. Then it's on to hatch opening. So it'll take about 2 hours after all of this is complete for the hatches to be open. At least that's what we're tracking on the timeline right now. In that space of time, they have to pressurize what's known as the vestibule. So that's actually the area of both Dragon and the space station that are normally exposed to the vacuum of space. That is now going to form a tight seal, and so they have to pressurize that. The crew will actually open up a seal manually and insert air from the station into that vestibule. And then they have to do a series of leak checks, obviously, just to make sure that everything is good before they move to opening the hatches. And there's a hatch on the pressurized mating adapter side, and there's also a hatch on the Dragon itself. And so that'll be coming up a little bit later, and then we'll actually see crew members go inside of Crew Dragon in space for the very first time.
They can meet Ripley as soon as they get inside there.
That's right. And there is one passenger already on board the Dragon spacecraft now, attached to the International Space Station.
2 if you count the 0G indicator.
That's right.
It's flying along with Ripley there. So for those of you just joining us, we did have a successful soft capture. Like we've been saying, it's going to take just a little bit longer with a lot more action coming up. So stay with us as we head towards eventual hard capture and then hatch opening. Be monitoring and ready to come back.
Ready to hook indicated. MCS reconfiguration in progress.
Copies and concurs. The undocking plate sensors are off. Congratulations to all of the teams on the successful docking.
And we copy in. Many thanks. Station Houston and 1, hook drive in progress.
Copy.
All right, and so the hard capture sequence is underway. We've already heard that the first set of hooks are in place. The second set now driving, so Dragon almost firmly attached to the International Space Station. Again, once this hard dock is completed, they're going to mate 2 umbilicals, which will actually provide some power and data to the spacecraft and allow it to transfer back and forth with the International Space Station. And you're going to hear calls throughout by NASA astronaut Anne McClain. That's who we're hearing right now. And then they're going to be on task to then start all the vestibule pressurization and eventually get the hatches open on the Dragon spacecraft and then go inside. And that's going to be the next really cool thing that we're going to be looking for in a couple hours from now.
That is true. That hard dock sequence, there are 12 total hooks in a ring all around the Dragon hatch, and they close those hooks by driving them, actuating them in sets of 6 each. And so we heard a call out for both the first set of hooks were closed, and we're getting close towards that full hard capture.
Probably hearing
Station Houston 1, we can confirm hard capture is complete.
Hard capture complete.
Excellent news.
That means that
Congratulations once again to a huge team around the world that makes it possible.
The second set of rings was fully retracted
and we concur
fully actuated,
the success of the entire teams around the world.
All right, so Dragon now firmly attached to the International Space Station. So now again, this is going to kick off about 2 hours or so until we actually get those hatches open.
Houston Station lab forward hatches open.
And so again, right now the crew's going to start. Moving in. They're going to open up.
And we heard you copied on the lab board hatches open. At this time, you guys do have a go to pick up in the first geo activity on David's timeline for the forward PMA leak check and opening the No. 2 forward hatch. Be advised that we're going to need 15 minutes for ventilation to be complete before we'll have you pick up in further PMA activities.
Copy that and works, and we have the Note 2 HD camera on.
Copy. We'll come on board with you guys.
All right, well, now that Dragon has completed that docking sequence, it's going to undergo a series of checks again. They're going to pressurize the vestibule, and they're going to do some leak checks, and then we're actually going to be able to open up the hatch. For now, though, why don't we send it over to Gary real quick. He's standing by in the International Space Station Flight Control Room. Gary, how's everybody feeling there? It's got to be great. I mean, Dragon's now attached to the space station.
Definitely good vibes in here, Dan. Actually, as soon as we got hard capture confirmed, we had a round of applause here in Mission Control Houston. It was a very exciting time. The beginning, really, of a new era of human spaceflight. This is like the first step until we start having commercial crew providers bringing humans to the International Space Station, launching from American soil. Once again, very exciting time. But for the crew, again, a lot of monitoring operations, successful retreat commands sent, everything. It was a very smooth docking for Dragon to the International Space Station, but still a lot of work to do. Again, like you said, they're going to be pressurizing the vestibule and then actually entering the hatch. We'll be covering that live. You might see them wearing hardline oxygen and taking some air samples, just part of the normal procedures for a new vehicle, or for this particular new vehicle, just to make sure everything is okay. And then maybe later on today, we'll be doing a nice welcoming ceremony to officially welcome Dragon to the International Space Station. So again, congratulations from the crew, from the teams here in Mission Control Houston. An amazing docking of Dragon to the International Space Station. A lot of work to do. We'll pass it back to you to really wrap us up, but we got a lot of work to do. Thanks.
All right, thanks so much, Gary. So we got this thing attached, and now again we're gonna wait a little while they pressurize the vestibule, do the leak checks, and then it'll be time for hatch opening. So we are gonna take a little bit of a break, but before we do, we have a special guest who's just about to join us. We just talked to Doug Hurley a little bit earlier in today's broadcast. He's one of those 2 commercial crew astronauts who's actually slated to fly a Dragon into space a little bit later this year. And now, if we can have him come run in real quick, we have Mr. Bob Benkin, the other NASA astronaut. Bob,
good to see you.
Good to see you.
Good to see you as well.
What's it like to see this thing dock to station?
Well, it's just been a super exciting week for us. We came from Florida after watching the launch, got on orbit, got activation done, and the next big milestone was autonomous docking and getting that demonstrated. And of course, the station crew is monitoring, but that's how we're going to be getting Dragon on board, docked on station in the future. And so it was just super exciting to see it. I know you heard the applause and all the clapping that went along with the accomplishment today. And so just one more milestone that gets us ready for our flight coming up here.
Now, Bob, how do you expect flying a Dragon 2 to be different than flying any previous spacecraft that you've flown?
You know, I came to the space station before 2 times with a space shuttle. A lot of manual flying associated with that. So arriving underneath the space station, making
Houston station on 1.
and then slowly coming into contact was all done manually.
Opening the Note 2 forward.
Controls. It took basically four people to monitor the systems at the same time that you were, accomplishing the flying task. Dragon's a lot different than that. Doug and I will do it for the first time together, primarily in a monitoring role. We may push a button or two to demonstrate that we have the capability to intervene if we need to, but the vehicle is pretty much going to do the work autonomously, just like it did today.
It's great to hear.
Yeah.
All right. Well, thanks so much for joining us real quick, Bob. Successful docking to the International Space Station, Dragon now attached. Again, so for now, we are going to take a quick break for about 2 hours while we wait for all the leak checks to take place, and then it's time for hatch opening. So we're going to see crew members go inside for the first time, and it sounds like everybody's getting pretty excited here at SpaceX headquarters.
So don't go anywhere. We will be back after a short break to cover the rest of hatch open when that comes around.
Canadian Space Agency astronaut David St. Jacques opening the hatch into the pressurized mating adapter. On the other side there, you can see another hatch. This is the hatch that will actually open up into the International Docking Adapter and allow and in between the International Docking Adapter and the Dragon capsule. Still a lot of procedures for David St. Jacques, and you saw NASA astronaut Anne McLean floating there as well. This is part of the ingress and basically pressurizing the vestibule and getting the pressure equalized between the International Space Station and Dragon and the International Docking Adapter in between, making sure that it's safe to open up the hatch. Once they do open up the hatch, they'll be on hardline oxygen, and that will be reflected once we do the hatch opening coverage here in just a few hours. David St. Jacques and Anne McLean will be conducting these procedures over the next about hour or so. And then in about 2 hours, we'll come back and we'll start broadcasting live to start doing the actual hatch opening coverage, where you see that soft cover in the background open, and the station crew members will go inside. We'll actually provide live views from the inside of Dragon if we are receiving them at that time.
And David, I want to let you know that we're going to move our USOS ops back over to Space to Ground 2. We have returned RSA-2 over to call 5, so you should have eye contact. And copy your thumbs up.
Moving over to 2.
Your 15-minute timer has now expired, and so you guys have a go to pick up in the next activity, which is the forward pressurization ingress part 1. You do have a go in step 2.2 when you pick up in that. And then also regarding the center disk cover, the field location for that will be node 2, deck 4.
Copy node 2, deck 4 for the disk cover, and copy go on step 2.2.
And one other item for the cover, if you could report the serial number, we'd much appreciate it.
Go.
You better split us, your base space. You better split us, your base, your base space. Split us, space. You better split us, your base space. You better split us, your base. It's been crazy. It's been a fun ride. It's been a fun ride.
have begun. So, what are we going to be doing today, Jeff?
We're going to be doing, well, doing our build grid, to put it very simply. We're going to be defining exactly how the building system is going to work and how we're going to turn a theoretical grid into some way to store data. So I drew a couple of things up here. In red right now, what I have is the basic representation of how our grid is going to work. We've already actually kind of started with this because we defined on our settlement we've defined on our player character a binding to a 10 unit by 10 unit. Was it 10 by 10? Was it 10 meter by 10 meter? We can double check that later. But anyway, we've defined where we can build items as positions on a theoretical grid, essentially. So what I'm proposing is that we actually turn this into representational data. So what I have here is just a 3D representation of a grid, or 2D representation of a grid, and then on the left is actually kind of what I defined as a building and how it would be shaped. This is its actual physical form, the shape that it takes. So what I want to do is try and explain exactly how the game is going to know whether or not it can place something somewhere or not. And the idea is that in Unreal we have our arrays, right? And so an array is a set of items, right? Well, all we really need is a 2D set of items in order to define exactly what we have here, right? So if we consider that a 2D set of items, we have one array, and then it's an array of arrays. And so what we're essentially going to do is, so disclaimer, Unreal does not support 2D arrays. It doesn't know how to do them. That doesn't mean we can't do them. It just means that we can't use Unreal's working implementation of them. So it gets a little bit harder, and it makes it so that our definition of this grid is going to have to stay in C++, but we can do it. So what we're going to do...
I'd rather learn how to do it that way anyways.
Yeah. What we're going to do is we're going to define our 2D grid, and this is going to it's going to cover our entire world. So instead of the settlement, the settlement is essentially going to have grid positioning. The structures themselves will pay attention to it. The settlement is a little bit more of an abstract idea, but it's going to be located somewhere on this grid. So we don't have to worry about merging settlements.
Right, because the settlement goes on this macro grid.
Right.
It's way spaced out.
Right.
And then everything else is based on the settlement, anchored from each settlement.
The objects are anchored to the settlement, but their location is not necessarily anchored to the settlement. So you could build in a straight line around the fucking equator, if that's what you want to do, and have it all be one settlement. It's purely metaphorical, or abstracted in that way. So we have our 2D grid here, right? So we'll fill it with numbers. I maybe didn't need this many grid points, but I wanted to have a bigger example just in case, right? Okay, so we have filled our grid with numbers, and the beauty of simple numbers in programming is that we can give numbers proper meaning with an enum. What do we want to call this? I almost forgot the E grid space state. No, E grid, yeah, space state. We can
for the settlements?
No. See, this is the cool part, right? So we're defining an enum, and we say none equals 0.
Run me through what an enumerator is again.
Okay, so an enumerator is a way to give syntactic meaning to basic values. It doesn't have to be a N32 enum, which is what we're going to use. But basically you can assign a word value like none, or I don't know. So at work we use it for animal types, right? We've defined an enum. 0 is like a dead case, it's a none. And then 1 is small, or I'm sorry, 1 is extra small, 2 is small, 3. And what that means is that when we're in code somewhere and we say we're passing size, we can just pass like well, you would say shit. So this gives us static access to these too, right? So I can say e that's really long. Okay, we're gonna change that. And then you just say egrid state :3. Or not 3, shit, fuck, I'm retarded. None. Right? And so if I pass this into a function, it's going to pass, technically, it's just passing 0. But when you look at this, when you read this, you'll know exactly what you're doing with it, right? So say we're comparing grid spaces and we say it must equal e grid space state none. Well, okay. Now our data, our number representations are mapped to like a semantic meaning. So what we do, let me get rid of this. You know what? I should have numbered that differently. You spell vacuum with 2 U's, right? Ben?
Hmm?
Vacuum?
Yes.
Okay. Quit texting.
Sorry, this is like...
Oh, work shit? I gotcha.
Just keep going.
So, we're defining an enum so that these actually have value. So the 0 state is mostly just for initialization purposes. And then as we determine what the different... what the grid values actually are, we fill them in. So basically, if we ever run into a situation where we see a 0 on our grid, we know that something wasn't initialized or that we have some sort of error. So what I actually need these to be are 1s. So let me spend my time here quickly fixing all of this shit. Okay. So, all of these are vacuum. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. All vacuum. So what we're going to do is all of our structures will have a defined grid space that they're going to take up. So we would say this is a 2, 2, 2, 2, 2. We'll start with 2 there. That one might not be quite the same. But because of the way that we have to define these, we'll also define empty space on them, which would be 1, 1, 1, 1. Boom. So we now have a 3x3 grid that represents a building that we can compare to our other grid. So it's really kind of that simple. The difficult part is going to be actually representing data in some way, shape, or form. Like I said, Unreal does not support 2D grids like this, but we'll find a way, whether through manipulating structs or by just kind of countervening Unreal and doing it purely in C++. Oh, right. So, separate numbers here. We have locks, and these are basically going to set it up so that we know that two buildings need to be connected at a single point. And this may change. We may be as simple as just saying there is a lock here, and if there isn't a lock, then... or if it is there, then it can connect from any side, sort of like a domino does, as opposed to defining a specific wall in which the lock is located. But that will come down to whether or not we have the ability to procedurally like set up like lock meshes or something along those lines. So let's just bring that in, and let's say that this building happens to have its airlock on the south side of this bottom piece right here. So this is going to be a 5. And so what we can do is we can take this, put it on our grid, compare, and say, oh, these are all vacuum where we're placing this thing. It can sit on there, right? Or if we happen to have a building already present, we can say this building is 2, 2, let's say 5, 2. So we have a lock right here that we know about, and then all we need to do is say, oh look, this grid is going to fit over here, and it's going to match its lock position right here. So if we take this building and put it in here, see, this is going to get flipped upside down. So this ends up being a 3 because it has the north lock. And then we have 2, 2, 2, 2. Now we have a fully pressurized space. Hope I didn't get rid of the outer. And what we do is once these two buildings have been connected, we disregard this, update, so that all the positions are 2. We have a proper lock connected between the two buildings, so there is no more position for attachment. Everything is just pressurized space at that given time. So yeah, it's a basic outline of how this is going to work. I'll probably end up having to go over it again here in a minute when Ben gets back from his work call. But hopefully we can start building this in. I need to do a little bit of research myself on figuring out how we're going to circumvent the limitations of UE4. And we'll be working on this all day. We have a little interruption with some work stuff that needs to be done. So we may just like take an hour or two break and then come back on again once that is completed here in the next half hour or so. In the meantime, I am still deleting things. We have been having quite the pained experience with our source control So now we're talking about setting up a static IP, hosting a Subversion repository locally, and working off of that as opposed to dealing with all of the external services that we've already been having problems with. And then I will also be working on the AI planning system. It got actually made some progress, figured out the way in which I want to represent, or the way in which we can solve the problem. So the usual implementation for A-star would be to track a list of active nodes, essentially. So in Unreal, we can set up a heap, sort them by lowest A-star score, and essentially as we're executing at any given point, if the heap contains an A-star score that is lower than what we're currently doing, we can push our current node to the heap and move on. And then we essentially do that until the top node on our heap is a goal state. And if it is, then inside of each of these nodes, we have a pointer to its parent node. And we basically are going to backtrack from the leaf of our tree to the root of it, which is the first action to be taken. And we can build a like proper plan that the AI can execute. Oh, you know what? I can actually pop open my screen right now, although it's not really showing anything except for some where you at, Streamlabs? There you are. Alright, it's trying to connect to the wrong fucking IP. I'm just manually do this here. Oh, well that's odd. Not showing anything? Alright, maybe we keep it on whiteboard for a little bit then, huh? Hey, Empress Moth. You'll have to excuse us. We need to fix a couple of code screens. Right now, you're just staring at the board. You missed my. I'm gonna say engaging description of how our build grid is gonna work. Actually, I better roll some of that shit back so that I can explain it to Ben again. Oh, thank you. Thank you. Yeah, I actually ended up getting S+ on all of them. Or I should say Leon A and Claire B. So I have both of those now. Infinite Rockets, all the jazz. Okay, there we go. Now we're back in order here. Alright, so let's see how we can set up this 2D grid. Okay. All right, we'll go over it again really quick. Okay, so our grid. Oh, I probably want to roll back this real quick. So I renumbered.
You're just talking normal volume because when you're over here, my mic picks it up, and then I have to keep muting and unmuting.
Oh, okay. So we have a grid, and then we're going to define a 3x3 grid, which describes this building. So 2 is pressurized. 5 would be a south-facing airlock.
That makes perfect sense.
And then the rest of our grid needs filled because it always has to be square around whatever object we're describing, right? So what this does is it allows us to really easily see whether or not a building can be built in any given space. And say we want to be able to match 2 airlocks to each other, we'll be able to snap pretty easily to that. So basically, we can take this whole thing, put it on here, and be like, do these numbers match, or do they interact the way we expect them to interact when we lay them on top of each other? Yes, you can build here. So at the same time, if we were to be like, there's a building here, and it's set up like pressurized, 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 and then this one has a south-facing lock right here, so it has a lock right there. We know.
So you're like, you can differentiate which way the lock is facing, so that when we build like structures or whatever next to it that have a lock, then it automatically, the game knows to connect those with like a mesh or whatever.
Yeah.
Okay.
Yeah. So what we can be is like, oh, okay. And so here's the thing, right? It's really easy to mirror this. So you just mirror it on the other side and then rotate it, right? And you end up with this right in here.
So each object's going to have one of these grid
arrays. Yeah, our structure
it.
data is going to be expanded with this. So because
which will make rotating structures in the build option like
really simple.
Yeah.
Yeah.
Cool.
So because we need these 2 locks to match up, this is going to be inverted. It's going to be mirrored on the x-axis essentially. So you end up with a north-facing lock, which is 3, 2, 2, 2, 2, and so we're like, oh, okay. So because all of these were vacuum before, we know we can build here. There's nothing blocking it. And because this is now a north-facing lock and this is a south-facing lock, we know that they can attach at that point. So we can place our building here, right? And it'll just fit. It'll update our grid. It'll say, okay, now all of these grid positions are used. They're safe. They have a lock, or they have pressurization and all that jazz. And then when we place it, because these 2 points have been mixed, we can now clear them and update them as pressurized links.
So, I mean, I'm just thinking about as far as the models go, like the meshes assigning, because they're assigned as a 2, wouldn't... I guess that's just a state.
It's just a grid state.
Data is going to have different meshes assigned for different states, right?
Each one of these grids positions isn't necessarily a mesh. This building could be shaped like I mean, like, that's the thing, like, right? We're basically just saying, okay, like, these are the grid positions that accurately match the grid space, so that's pressurized, and this is a lock. So if we want to make a big ass building that's as big as this entire grid, we can do that, and we have a way to define how it fits on top of our grid system.
Okay.
So yeah, it's actually pretty simple and straightforward. The tricky part is just going to be representing that in a meaningful way, and we're probably going to want a way for it to be represented in the engine, because, you know, as you go to build, it's like StarCraft, right? They always show you a virtual grid that you can build on, so you know exactly where the part is going and everything like that.
Should we have an medium value for elevation, like more than a whatever slope, or there's a cliff side, or are those gonna have?
That's a good point.
It's like,
I was thinking purely in 2D. We wouldn't want to fit that into the state, but that doesn't necessarily mean that we can't store more data on any one of these grid
I
points.
guess none would be. You just make that unbuildable.
Yeah. Well, so the reason why we put 0 none is because it's like a really fast error catch. So if we ever have a problem, we can be like, oh, well, grid state equals 0, and then if that's ever run into, it's like, oh, we had something go wrong here. We need to fix something. Okay. Like for us, not for the game itself. Like it's purely more of like an error catching sort of thing.
Okay.
So yeah, that's it, really. What we want to do first is figure out the method in which we're going to represent the 2D grid, whether that be by creating a struct with an array, or like an array of structs, because Unreal, like I said, it doesn't support 2D arrays, because in C++ you can literally just define an array with like a nested array, and it just works as a 2D grid perfectly.
Okay.
But it's not quite that simple, and I just like started really looking to figure out exactly how we would fix that problem. And like I said, one of those might just be we'll just make a C++ grid and then only ever like call external functions to check whether or not, like, to check grids against each other. But ideally, because this needs to be mapped to the building, I would like to do it without having to actually create like a separate map of like building IDs to grid systems. So if we can
keep it all the same.
If we can find a way to create these 2D grids reasonably inside of the engine, then we should do it. But the first thing,
it doesn't support 2D arrays. But what does it support? Unreal.
So the first workaround that most people use is inside of whatever object that's going to hold this data, they create an array of a struct that has an array in it. And that's like a pseudo 2D array. It functions as one, but it's not one in like data terms, essentially. I happened to look at my screen, and for whatever reason, it was just straight black. Oh, you don't have TeamViewer up, do you?
No.
That's what it is. Server sent... Oh, God damn it, dude.
You can also make it work like a pointer.
What, you mean like a void pointer? Like an array of void pointers or something like that? Because Unreal itself can't process arrays of arrays. It doesn't do it.
You have to open TeamViewer.
Oh, yeah.
The arrays.
Well, I would test it myself, but my fucking editor isn't currently running because I've been having subversion problems still.
Wait, did you rename the... You pulled back down again?
Yeah.
Recycling the trunk folder?
Yeah, I mean, I'll try pulling it down again, but there's nothing in it, so it's not really of any use to me.
What? Should be what's in everything. What everything's in, I mean.
Nope. It just said it's saying that the folder is in conflict. It's that old chestnut.
Well, before we start working on this grid, should we figure out this SVN server?
That could take all day. We have to install 2 separate pieces of software, set up both. One of them is an SVN server, like software package.
Okay. Can I get started on that?
Yeah, you can download Visual SVN and dynamic, what is it, free dynamic DNS. And there's an actual bit of software called free dynamic DNS.
Visual SVN 6.3 supports Visual Studio 2017 only.
Well, then don't get that version. Download an older version.
Unreal's documentation also recommends that we use 2017. Because it has full version control integration and Unreal integration and stuff.
I don't know if Visual Assist works with 2017. Oh, it totally does.
So we should do that, yeah.
That's
another thing to figure out. I mean, like, these are quality of life things, you know? I think these are worth our time.
I'm not saying it's not worth the time. I'm just saying it's not very much of stream material.
I feel you.
The arrays can be pointers to other arrays, I'm guessing is what you're trying to say, but yeah, Unreal Engine doesn't really handle that shit very well. So we have to find a workaround, and usually what I do when I need it to be engine accessible is set up structs. It's like a struct that has an array in it, and then inside of whatever object I just create an array of that struct. But that's not really easily modifiable, so I was really hoping for a better way to do it. But we'll see what we can do.
Visual Studio Community 2017, here we go. So should I delete 2015? Or uninstall it?
Yeah.
Alright, sick, dude. Yeah, because I've been reading that everywhere, and I didn't want to press the issue, but... God, it was still parsing. It's fucking crazy. Even on an SSD. Oh, it's my CPU, that's why. Has the stream been running smoothly, Empress? Because my computer has been chugging CPU. So I'm just curious if my priorities, my CPU priority is actually doing anything. Sweet. Above average for the win.
Take it.
Actually, I might have set this to even higher than that. Well, Streamlabs has a process priority like option, which is something you rarely see in any software. Alright, VS Community. Oh, let me add, remove 2015. Because what do you guys use at work?
Subversion.
No, yes, but what do you... Oh, that's good to know. But what do you guys use at work for VS?
15.
15, interesting. So you're positive the Visual Assist license that you guys have is good for...
Pretty sure.
Okay.
I mean, considering the most recent update one that it keeps asking us to get added Visual Studio 2019 preview support, so...
Right, I mean, 2017 came out, well, what, probably in 2016?
Mm-hmm.
So 3 years ago.
I see, it's gonna fucking fail again, dude. Alright, this time I'll just destroy the fucking engine folder and hope that it pulls it down correctly. Something was missing, it wasn't building correctly, so I don't know what the fuck went wrong. Oh man, it's a goddamn nightmare, is what it is. Gonna have to reinstall Visual Assist too. Yo, Ben, your mic is active. Okay. Are you gonna be in here or what? No? Okay. Cool. Cool. What's that? No, we don't care. Yeah. Wait a minute, past that point? Huh? Say that again? Oh, it integrates seamlessly with Visual Studio? No, just do the server. Because we don't want to be forced to work through Visual Studio's extra baggage. I like how Visual Studio has to configure my system to remove itself. Yeah. That's fine. If I can at least get this fucking engine building. Okay. We'll get there eventually. Alright, I think my engine folder is being properly pulled down now. Yeah, sorry. It's a little boring right now because we're just doing fucking administrative bullshit. Dealing with this server, and I'm pulling down all of the engine files again so that I can rebuild the engine for the umpteenth time. Thanks, I appreciate it. Good old engine. For this. Wait. Character design work for a Lovecraft-based fighting game. Where's the other stuff? This guy, Hambo, did some stuff. That's his initial pass at one of the characters. Yeah. I made a state machine for it, but then it kind of stalled. And then we started working on this, and now it's like just kind of like ruminating. Yeah. It's like fucking 85 ideas for games. I gotta make all of them eventually. Yeah, that makes sense. Yeah, Nina has been looking for work now for like 10 months. It's taken up a lot of her time. Even though she has a job, it's still just like a pain in the ass to constantly be applying different places. Space is awesome. Actually, I've been thinking about it a lot. I think that like the atmosphere of like Mars and like your ability to write something that is like Lovecraftian within that environment would be a perfect like mixture. So I've also been thinking of different ideas, because I do very much enjoy Lovecraft's mythos and like the idea of cosmic horror, and I think it'd be really cool to do a cosmic horror based game on Mars, like a inside of a colony or something like that. Oh, it's a shame you had phone problems. It really sucks. Still just pulling latest. Ah, yeah. Good stuff. God damn. Okay, we gotta be getting close to the end of this. It is LA, man. the best way to possibly do this and have it be easily modified. Can we just... But it blows up. Can't have containers of view object values, only object pointers. Okay, however, as mentioned, I probably also want to wrap the inner array in a U struct and then make level map a U property as this will allow garbage collection to work correctly. Oh, garbage collection won't work otherwise. That's rough. Yeah, we're just gonna have to do this the hard way, I think. There we go. Finally fucking remove Visual Studio 2015. Now let's add 2017. Well, if Incredibuild's already... Yeah, that'd be pretty fucking cool. Does the C drive on this thing have enough space for it? Yeah, it does. Okay, oops. No. I've never used CryEngine's sandbox tool. Why do you ask? Don't need .NET, don't need Azure Node or any of that shit. Visual Studio .NET cross-platform. Alright. Should be able to just install that. It'd be pretty cool if I could create a custom editor tool for filling these grids in and make it a lot easier to define how they are. Oh yeah. Well, we know the data we want to generate our environment from, but actually doing it is going to be a little weird. We have actually been looking at UE4 voxelization tools as well, so we'll see. We'll see. We'll either end up testing / settling on one of those, or end up having to implement our own system. Not really sure yet. It's going to be kind of tricky though, because we need things to still operate on the far side of the planet, so assuming the voxel engine culls voxels behind, we need to ensure that everything still runs smoothly on the opposite side of the planet you're looking at. So there's going to be some working around problems one way or another once we get to that. Wondering what they make with this and see if it's actually useful. Oh, yeah, they do have a separate property editor.
Undo mirror about plane, you can see they pop back to the conversation. And so this can go, you know, arbitrarily more complicated. Like if I were actually, you know, modifying a particular value on a
getting simple overlaps is not really robust.
Tutorial, which is just going to be a short one, we're going to be going over
the background is working for us. I'm going to snap it to a grid of a certain size.
realize that your life isn't about you is the moment your life really starts, honestly.
Shit is still minus. Shit's still installing. That's pretty cool, but not really useful. I guess we're just gonna have to do this the hard. Could create a fucking like a XML or otherwise spreadsheet importer for it. That might actually be the way to go, because then we could literally just like text document, pop it open, set it up as a CSV, and just define it, you know, 0, 0, 1, or I should say 1, 2, 2, 1, 2, 2, 1, 1, what did I call it? South block 5, and then that's technically defines our item that we were doing up on the wall, or I guess this defines the Y mirrored version of it.
This level of fidelity, things like setting up the widgets and everything, will not be taken into account in the engine. So if just give you a quick look at things like the existing project I have, when we see this in the engine, we'll see that we actually count in the engine. So if just give you a quick look at things like the existing project.
Oh my god. You can fucking hear the echo from this video. That's awful. Oh, he's doing it all in blueprints. We don't need to do that. We can actually read from fucking file. This would be ideal. We could really easily read files and modify the grid spacing for any building that we create. Okay. All right, BRB.
the very
Just constantly pulling down. Fucking can't even set up the CSV import functionality. Shit failed to pull down again. I don't know what the fuck is going on with it. just does the same damn thing, man. Every fucking time. Gets to a certain point and then it just stops fucking pulling latest.
to ever last. I've fallen. Love too fast. I've fallen. Love too fast. I fall in love too easily. I fall in love too fast. I fall in love too terribly hard for love to ever last. I've fallen. Love too fast. I've fallen.
Oh, you didn't miss anything, actually. I'm still just fixing shit here, so I figured I'd leave up the cool images as opposed to my screen full of just fucking, like, Windows command prompts. Yeah, we're gonna take the stream down here for a little bit. Be back in like 20 or so minutes.